Hey, algebra students. Here in lesson 4, starting the second half of chapter 4, we get to the practical part of logs, and that's finding the missing exponent. And the way that we do that is with the change of base theorem. So today in this lesson, we'll be doing learning target 9, write equations and solve equations using the change of base theorem, and hopefully especially for application questions. So a few things first. What is a common logarithm? Well, most of the time, a log is just like this. So if I said log base x, well, that would imply log base 10 of x. And in fact, on uh, your calculator just assumes base 10. You would actually have to go in and manually change things to make it a different base. So the log button is just assumed base 10. The other main logarithm is the natural log. And the natural log is simply log base e of x. So this isn't like an inverse necessarily. I mean, it is the inverse of e, but this isn't something separate. It's just a different way of writing log base e of x. And then the big thing, the change of base theorem. Well, here it goes. It says log base a of x is equal to log base b of x, so the big thing here, divided by log base b of a, your base here. And so the big idea here is I can solve this log with any base by converting it to this, and this will just give us the important thing. That's the missing exponent. So remember, the answer to a log question is the missing exponent in your exponential equation. So this is a very, very valuable thing. All right, so quick few little things. You're going to be using your calculator today. So log of 1,000. Well, hopefully you could probably do this one without a calculator. You know that this is the same thing as log base 10 of 1,000. And so this is like saying equals what? Well, this is like saying 10 to the what power equals 1,000. Well, you can do this one in your head. 10 to the third is 1,000. And so when you go ahead and press log of 1,000 on your calculator, that's why you wind up getting 3. Now log of 42, that would be log base 10 of 42 equals what? And again, so if I'm thinking about this, I got 10 to the what power equals 42. Well, 10 to the first power is 10, that's too low. 10 to the second power is 100, that's too big. So it's somewhere in between 1 and 2. So here's where we go to our calculator to get the exact answer, and that's just going to simply be, go ahead and do log of 42, and you wind up with, it looks like approximately 1.6. All right, and then over here you got log and then a decimal, a pretty small decimal at that. Well, again, if I'm thinking about it, this is log base 10 of 0.005832. And so this is like saying 10 to the what power equals this. Well, let's see, 10 to the 0 would be 1, so that's too big. 10 to the negative 1 would be like 1/10 or 0.1, that's still too big. So we know it's going to be less than that. So again, when we go to our calculator, we wind up getting that actual answer, and x is equal to negative 2.234. Okay, so that's using your calculator and kind of why it's working out that way. All right, so here is an application question. It says find the pH of a solution with this. I'm actually going to shorten this up a little bit. We'll just kind of combo these two things. We'll replace this with 6.3 times 10 to the negative fifth. So we'll just do it one time. So we got this situation where the pH value of the water in a wetland is what is how we describe it. So if it's a rich fern, that means the pH is between 6 and 7.5. It's a poor fern or fen if it's between 3 and 6, and less than 3, it's called a bog. So that's really acidic. So the formula that you need to remember here is the pH is going to be equal to the negative log of the H3O plus. So in this case, the pH is going to be negative log of 6.3 times 10 to the negative fifth. Now, you could put this all into your calculator. I think you would probably get the answer. If you do that, I'll give you a 4 out of 5. What I'm really looking for here is for you to display some of your knowledge of the other things, like knowing that this would be the same thing as negative, and we'd say log of 6.3 plus log, or I guess we could say negative 5, so we'll bring the exponent down front, so negative 5 log of 10. And, well, negative log 6.3 is going to be about 0.8, okay? So kind of going through the process that we saw on the last screen, probably just using your calculator. And then log base 10 of 10 is actually be 1. So like 10 to the what power equals 10, well, that'd be 1. And so 1 times negative 5 is going to be negative 5. So minus 5. And then, well, negative 5 plus 0.8 is negative 4.8, or sorry, 4.2. And so we get positive 4.2. And we take a look. All right, 4.2 looks like that's this one. And so we would call that a poor fen. All right, moving on to some other things. Here we are looking at E and natural log. So again, remember, this is the same thing as saying log base E of e to the third equals what? Well, it's like saying e to the what equals e to the third. Well, these e's are going to cancel out. We just get x equals 3. Okay, so if we had done that one on our calculator, we get 3, no problem. Now again, thinking of this here, this is like log base e of 142 equals what? In other words, e to the what power equals 142. Well, that'd be like 2.71 to the what power equals 142. Well, 2 or 3 to the 1 what power equals 140. That would be complicated enough. So the fact that this is an irrational number makes me really glad that I have a calculator. And so natural log of 142 winds up being 4.96 approximately. So if I plug in 4.96 in here, 2.71 dot 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 to the 4.96 dot dot dot, I'll get my 42. All right, let's skip down to here and start working with the change of base. So I've got a base of 5. It's like saying 5 to the what power equals 17. Well, gosh, that's going to be a little bit difficult. If it were equal to 25, that would be no problem. It'd be squared. But being 17, it's going to be somewhere between 1 and 2. How's this all going to work out? Well, here's how it works out. The solution is we're going to do the change of base. We're going to say the log. Now, we could either do log or natural. It doesn't matter because remember in our change of base formula, it's just base b and base b. It can actually be whatever log I want. Log base 10 happens to be convenient because that's what my calculator uses. Natural log uses base e. So as long as they're the same base, it's good. And so you can use either log or natural log button on your calculator. But make sure the big number here, I guess 17, the largest number, goes on top. And then log of 5, the tiny number, the base, goes on bottom. And we'll just do this on our calculator. And it looks like we get approximately 1.76, which 5 to the 1.76 would give me 17. All right, you can do that one on your own if you'd like. We'll skip over to the last application question. So here we're measuring the diversity of a species. So like pH is a measure of acidity, this H value is going to be the measure of the ecological community, how diverse things are. And so P1, P2, all of these, so you got like first term, second term, dot, 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 last term. So you're just going to do this as many times as we've got species. And the P1s and the P2s, well, those are the proportions of the species. So if I've got two species and there's 90 of one and 10 of the other, that means that there's 100 species altogether. So we'll say P1, we'll say the first species, 90 out of 100, which would be 0.9. And then the second species, P2, it'd be 10 out of 100, or 0.1. So at this point, my H value that is gauging how diverse the community is, well, we'll say 0.9 of log base 2 of 0.9, and then plus 0.1 log base 2 of 0.1. All right, well, moving through this example here, all I really need to do is do the change of base, log of 0.9 divided by log of 2, take that and then multiply that by 0.9. We can do those things on our calculator and we get negative 0.1368. And then here, same thing, log of 0.1 divided by log of 2, and then take that answer, multiply it by 0.1, and we get negative 0.332. And so my final answer here is negative 0.46899. And so I don't know exactly what this H is. I got what pH value is. I'm not familiar with the H value here, but I imagine it's somewhere on a spectrum, like the diversity of your community is pretty low if it's below 0. So that's it. Here are your practice for your learning target.